Hi there. On this episode of Mathematica from scratch, we're going to look at plotting. We're just going to look at some basic two-dimensional plotting, and in a further episode we'll look at 3D plotting and some more advanced stuff. But just to get started, let's write down maybe a couple of equations or functions and see how we can plot them. Okay, so over here I've started up Mathematica. I'm just going to type the plot command. It's really important that you start the command with a capital P, and we're going to be using square brackets on either side of the command. Just as a side note here, if you go to Help, Online Documentation, and type in plot or plot 3D or something, you can get all the details on how this command works. So we'll just plot maybe a simple function, just x squared here. And what we can do is use curly brackets to tell it we want to plot and we want to change the variable x from maybe -2 to +2. We're going to close the curly brackets, close the square brackets, and shift enter in order to evaluate it. So there we go. There's our plot of x squared. We can change this. We can go maybe x squared -2 and plot it over the same range. And you can see how that affects the output. And to me, this is a really good way to get used to different polynomial equations, for instance, as you can kind of plot them and see for yourself how going from x squared to x cubed is going to change the plot. There's a better way to do this, and we'll talk about that in a second using the manipulate command. So that's just a really basic plot command. Let's look at another one for maybe a trig function. So we're going to plot the sine of x. So I'm going to use a capital S for sine function of x, and we're going to plot it with respect to x from let's say -2 pi to 2 pi. Okay, and just hit enter, and there is our sine function. Remember the keyboard shortcut for pi. If I go up here and just go backspace to delete it, if I hit escape and then the letter P and then escape again, escape, P, escape, it'll substitute that in for the pi symbol, and that just makes it look a little nicer. But the equation and the plotting function works just the same with either one. Let's say we want to combine a couple of graphs and plot a couple of things together. So let's try plot. And if I want to plot two different functions on the same graph, I can use a curly bracket and go sine of x and maybe x cubed, like that. I'm going to plot both of these functions from x of -pi to +pi and hit shift enter, and it actually creates both graphs together, and it's going to color them differently. So the first line, the sine function, is in blue here, and the x cubed function is in kind of orange. If we want to change the range that we're plotting over, maybe zoom in a little bit on the central region, we can do that. Or we can extend it from -2 pi to 2 pi. I'm just going to show you something here. There we go. Now, plotting automatically the plot function tries to choose the range to plot over. But sometimes we want to specify that ourselves. We want a little bit more control over what's being shown. So what I can do is add a comma and type the plot range here. Using an arrow, and I'd like to go from, let's say, along the x-axis from -2 to 2, and along the y-axis from, let's say, -5 to +5. So I can specify the plot range, and it's going to zoom in now on the central region of the plot from -2 to 2, from -5 to +5. And that's how we can limit that plot range rather than just letting it do its default values. Okay, so just another addition here is the use of the manipulate command. This is super, super powerful, and it can be combined with plotting to make an interactive graph really, really simply. So the function I want to plot is I want to plot, let's say, the sine of x, but I want to be able to vary the magnitude of my sine function as well as the phase. The phase, I'm going to use the symbol phi. It's just a Greek letter, so escape, phi, escape. And the amplitude of my sine function, I'm going to call a. Notice if I have the a right next to the sign here, it thinks that is variable, and we don't want that, so I need to put a space between the a and the sine, and see the color of the sine function changes. It knows that it's a sine function now. So I'm going to plot this from x from minus pi to pi, minus pi to pi, and there is my plot, and I could just hit Shift Enter, but it doesn't know what a is and it doesn't know what phi is. They're undefined variables. So what I'm going to do is, within the plot, I'm going to put it inside a manipulate command. And now I'm going to say we want to manipulate this function with respect to a from maybe -1, or let's go from -1 to 1, and with respect to phi from 0 to 2 pi. Okay, now this is going to do something really amazing with the plot function if it works. Oh, something didn't work here. Let's see here. Let's see here. A from -1 to 1, x from minus pi to pi. There we go. Okay, so let's see what we've got here. So here is the output. We've got a sine function here. The phase phi can be manipulated, and there's a slider here and a way to display it, so we can change that phase delay for our sine function. We can just see the result of it here. We can also vary the amplitude just with the slider here from -1 to 1. And what you see is the axes of the plot along the y-axis are changing. We can't actually really see the effect of varying the amplitude in this figure because it's automatically adjusting the y-axis. So to fix that, let's just add that plot range here. So plot range within the plot function along the x-axis, we're going to go from -pi to pi, and along the y-axis, we're going to go from -1 up to 1. And now, when we do this, the y-axis should be fixed. So if we change the amplitude of our sine function, we'll actually see that being reflected here, like this. The phase can be varied, and we can even animate these things, for instance, by hitting the play button. So this is going to just continuously vary the phase as a function of time. So that's a little bit on plotting and manipulating for two-dimensional graphics. Thanks, and tune in to the next episode.